Hello, welcome to my channel, and this is part 2 of Light, Reflection and Refraction, Class 10, Chapter 10. So let's start with our video. So, in this video, we are going to learn about the ray diagrams. So here, how to represent the images formed by spherical mirrors using ray diagrams. So, consider an extended object of finite size. So, finite size in front of spherical mirrors. Each small portion of extended object acts like a point of source. So, the object which is placed in front of the mirror should be of finite size. Extended object act like a point of source. An infinite number of rays originate from each of these points. It is more convenient to consider only two rays for the sake of clarity of the ray diagram. So in ray diagrams there are many rays we can originate, but we only use two rays to consider that, because for the clarity of sake, so that our diagram looks neat and clean. The intersection of at least two refracted rays give the position of image of the point object. There are four rules to draw the image formed by spherical mirrors. So first rule is a ray parallel to the principal axis after refraction will pass through the principal focus in case of a concave mirror. So this is a concave mirror. So a ray parallel to principal axis will after reflection will pass through the principal focus. Focus is here, and it appears to be diverge from the principal focus in case of convex mirror. So in convex mirror it always appears to be diverging, but it is not diverging, it's just appearing. But in concave mirror it passes through principal focus. And the second rule is a ray passing through the principal focus of a concave mirror, or a ray which is directed towards the principal focus of a convex mirror after reflection, which will emerge parallel to the principal axis. A ray passing the center of curvature of a concave mirror, or directed in the mirror direction of the center of curvature of a concave mirror, or directed in the direction of the center of curvature of a convex mirror after reflection is reflected back along the same path. So in this case we can see a ray. This is the concave mirror and this is the ray diagram of the point I told you right now. So in this ray diagram we can see if the rays passing through center of curvature will reflect back through the center of curvature, and the light rays come back along the same path because the incident rays fall on the mirror along normal to reflecting surface. And fourth point is a ray incident obliquely to the principal axis towards a point P on the concave mirror is reflected obliquely. The incident rays follow the law of reflection at the point of incidence, making equal angles with the principal axis. So here we can see that when the ray comes on the principal axis pole, then it will diverge obliquely. Here it is also, this is only happening. So there are 6 important ray diagrams which are really important in the NCERT of class 10th. So how to image formation of spherical mirror. So first of all, for concave mirror, if the position of the object is at infinity, so if the object is at infinity at the so the position, so here is the object and the position of the image will be at focus. So here we can say that the image is forming on the focus if the object is kept at infinity. It can be kept any far, then also the image will form on the focus. So there are two rays coming, as I said in the rules that only two rays we have made for the clarity of the diagram, and we can make more. There are infinity rays we can make. Okay, so this is the center of curvature and this is pole, and you can see that the image is highly diminished in point size. It is really small. You can see it here, really small, and it is real and inverted. It will form in the real world, not behind the mirror. In case 2, you can see that the image is beyond. C means center of curvature. This is the image, and this is the object B, which is beyond C, and the image will form between focus and center of curvature. And here also the image will be diminished and same size, and this image is also forming inside the real world, and the object and the size of image will be same. In third case, the object will be kept at C, and we made two rays like this and like this. So image is also forming at C, because the object is also kept at C. We learned from the rule that if the object is kept at C, then the image will also form at C. And in the fourth case, we can see that the object is kept here between center of curvature and focus. So two rays goes, and the image will form beyond C. And the fifth case, the object is kept at focus, and the image will form at infinity, and the image will be highly enlarged, will be really big, and will be in real and inverted. And the last rule, in this last case, we can see the object is kept in front of the mirror, and the image will form behind the mirror, which will be virtual and erect, and the object is kept between focus and pole. So we have learned the 6 cases of concave mirror. Now let's move to convex mirror. So there are only two cases of convex mirror, and always the image will be virtual and erect, and always form behind the mirror, not in front of the mirror. So in first case, the object is kept at infinity, and the image will be at the focus F behind the mirror. So the image will be point sized and highly diminished. And in the second case, we can see that the image is between infinity and pole, and the image will form between pole and focus. Here this is the image A dash B dash, and it will be highly diminished and virtual and erect. So our ray diagrams are done. Let's move to the uses of convex and concave mirror. So first we'll learn about the uses of concave mirror. It is commonly used in torches, searchlights, and vehicle headlight to get powerful parallel beam of light. This is because when a lighted bulb is placed at the focus of a convex reflector, then a concave reflector produces a powerful beam of parallel light rays. This helps us to see things around to a considerable distance in the darkness of night. Concave reflectors are also used in room heaters. The concave reflectors of room heater direct heat rays into the whole room. It is also used as saving mirrors to see a large image of the face. This is because when the face is held within the focus of a concave mirror, then an enlarged image of the face is seen in the concave mirror. This helps in making a smooth save. For the same reason, concave mirrors are used as makeup mirrors also. Dentists use it to see large image of teeth of patients. And large concave mirrors are used to concentrate light to produce heat in solar furnace. So let's move to uses of concave mirror. For convex mirror, image is formed, so they are commonly used as near view mirror in vehicles. You might be thinking that we can also concave mirror also, but no. We cannot use a concave mirror as a rear view mirror in motor vehicles. This is because concave mirror produces inverted image of distant objects. So if we use a concave mirror as a rear view mirror in a car, we will see in the mirror that all the vehicles on the road are running upside down. That's why we use convex mirror. They are preferred because they make erect image. They have wider field of view as they are curved outsides. Sign convention for refraction of spherical mirrors. In this convention, the pole of mirror is taken as the origin and the principal axis of mirror is taken as the x-axis of the coordinate system. The object is always placed to the left of the mirror. This implies that the light from the object falls on the mirror from the object falls on the mirror from the left hand side. All distances parallel to principal axis are measured from the pole of the mirror. All distance measured to the right of the origin are taken as positive, while left of the origin are taken as negative. Distance measured perpendicular to above the principal axis are taken as negative. Distance measured perpendicular to and below the principal axis are taken as negative. So these sign convention for reflection by spherical mirrors are really useful when you do numericals, and in next video I'll give you many numericals to solve. So thank you for watching. Please subscribe, like and share. Meet you in the next video.